So when we apply force on the object will show a deformation. We have this formula for Hooke's law. K is equals to F divided by A, where K is a spring constant, F is a force acting on the object, and E is a extension or compression or change in length. Or extension or compression. Same thing. Change in length, extension or compression. Now if I say a question is there, spring of length, five centimeter without load. So when there is no load, the length is 5 centimeter. Calculate spring constant if its length changes to 12 centimeter by 20 Newton force. So there's a spring and the length of a spring is 5 centimeter without a load. That's called the original length. When nothing is attached without any load, its original length is 5 centimeter. When you attach a load to this, the length of a spring changes, and when you attach a 20 Newton load, length of this spring changes to 12 centimeter. And you have to calculate a spring constant K. So spring constant K is equals to force divided by extension, or force divided by compression, or force divided by change in length. So here the force which is acting is 20 Newton, but what about extension? What is the extension or change in the length? Originally it was 5, now it is 12. So what is the change in the length?
7.
So it will be 7 because the difference, that increase in the length, so that's equal to 12 minus 5, which is equals to 7. So force equal 20 and extension is 7. So 20 divided by 7, it will be 2.85. And what is the unit? Newton per centimeter. Why I took centimeter? Because the length is in centimeter, that's why I took in centimeter. Is it clear? Discussion. So what does it mean 2.85 Newton per centimeter? It means it required a force of 2.85 Newton will produce 1 centimeter extension. Is it clear? Sometime the spring does not follow the Hooke's law. After certain load, spring does not obey the Hooke's law. Means when you're adding a load, the spring is following the Hooke's law, but after some time, the spring does not obey the Hooke's law. How you can identify that? If I say you have a table for force and extension, for example, if we have force in Newton and extension in centimeter, originally the force is 0, extension is also 0. We apply a force of 10 Newton, 20 Newton, 30 Newton, and 40 Newtons. The extension was 4, 8. So extension was 2, 4, 6, or 2, 4, 8, and 20. The question is identify from the table which point, after which point the spring does not obey the Hooke's law. So how you can identify from a table point where the spring does not obey Hooke's law? As you know, if it is obeying a Hooke's law, the ratio should be constant. The ratio between force and extension should be constant. So when I take a ratio of force divided by extension, I should get a constant answer. First value is 0 and 0, we don't have to do. The second value 10 divided by 2, which is equals to 5. 20 divided by 4, that's equal to 5. But the third value is 30 divided by 8. So 30 divided by 8, that's equal to 3.75. And the next value is 40 divided by 20, which is equals to 2. So can you identify at which point the spring start or does not follow the Hooke's law from this table? So this is the first point where the spring does not obey the Hooke's law. So the last point where the spring is obeying a Hooke's law, the point before that, this last point where the spring was obeying a Hooke's law, this point is called limit of proportionality. So this point where the spring was obeying a Hooke's law, the last point where the spring was obeying a Hooke's law, we call that as limit of proportionality. After that, the spring does not obey the Hooke's law. From the graph, how we can identify? So if there is force and extension, if force is on y-axis and extension is on x-axis. So when the spring is obeying a Hooke's law, it will be a straight line. And after that, it will become curve. So the last point where the line is straight, that point is known as limit of proportionality. So limit of proportionality, after limit of proportionality, we increase the force. The extension is also increasing, but not with the same pace or same rate as it was initially. So if there was a table given to you, just take a ratio between force and extension. The point where the force and extension, the ratio is not same, it means it is not obeying the Hooke's law. So the point before that is known as limit of proportionality. And if you sketch a graph, if you sketch a graph, because you're increasing a force, so it will. What about 40 and 20? 40 and 20 are the points after limit of proportionality. This also, it does not obey the Hooke's law. Because, so once it started to obey, means initially it is obeying the Hooke's law, but there will be a point after that it will not obey the Hooke's law. Is it clear? Then there's another point which we define for the Hooke's law. We call that as elastic limit. So after limit of proportionality, there's also another point which we call anywhere after limit of proportionality, you can mark another point, and we call this point as elastic limit. So what is the meaning of elastic limit? Elastic limit means after this point, spring will not return to its original length, or after this point, spring will deform permanently. So practically, you can find the elastic limit theoretically, like on the graph. You cannot identify, you just have to mark this point. So what does it mean, elastic limit? If we have a spring, and the length of the spring, say 10 centimeter. I add a load to this spring. I add 100 Newton load, and its new length, originally it was 10, its new length is 15 centimeter. If I remove the load, it should return back to the same 10 centimeter, but it does not return to same 10 centimeter. So if the object, if the spring does not return to the same original length, it means we cross the elastic limit. So spring does not return to same original length, it means we cross the elastic limit. So these are the points for a Hooke's law, that the formula is there. First thing, the formula according to Hooke's law, K is equals to F divided by E. Then the point where the line is straight, we call limit of proportionality. If the spring does not return to the same original length, we call that the spring crosses its elastic limit, or it is deformed permanently. Elastic limit from the graph you cannot identify exactly directly. It's just a rough idea, because elastic limit can only be found practically. So if in exam, if it was given that mark elastic limit and limit of proportionality, so first thing, the last point where the line is straight, that's limit of proportionality. Then after that, so this is the point P is the limit of proportionality. Any point after limit of proportionality you can mark anywhere, and that is called elastic limit. Limit of proportionality means that force and extension are directly proportional to each other. The ratio is constant. Elastic limit means when you remove all the loads, if the object return to the same original length, we call that we are within the elastic limit. If it does not return to the same original length, we say we cross the elastic limit or the spring is permanently deformed. So elastic limit practically you can identify. Theoretically on the graph you cannot identify, but you in exam when they ask identify or mark elastic limit, so you can mark any point after limit of proportionality, or even on limit of proportionality you mark, that's also acceptable. But practically elastic limit you can identify only by experiment. Like once you remove the load, what will be the, if the spring return to the same original length, you will say you are within the elastic limit. If you add a load and then remove and spring does not return to the same original length, it means you cross the elastic limit. So if you have two springs and you want to identify from the graph which is having higher value of a K. If you have two springs with different values of the K, which spring is having higher value of a K, spring A or spring B?
Spring A.
So higher value of a K, because I told you when force is on y-axis and extension on x-axis, the slope represent K. Slope means angle. So slope represent the value of the K. When you check the angle of A with angle of B, so you'll find A is steeper as compared to that of B. So spring A is having a higher value of a K as compared to spring B. Slope or the gradient, same thing. Slope, gradient or angle, you just measure the angle. But keep in mind when force is on y-axis and extension on x-axis. When you have two springs which are having different value of the K, so how you can identify which is having a higher value of a K, you can check the gradient or slope or angle. The one which will have higher gradient or angle or slope will have higher value of a K. So you can check with x-axis, angle of A is much greater than angle of B. That's why it will have higher value of K. Which spring is difficult to stretch, A or B? So higher value of a K means difficult to stretch. So A is having higher value of a K and A is difficult to stretch. So when the materials are difficult to stretch, we also use the term stiff. So which is stiffer? A is stiffer than B. Stiffer or stiffness refers to you need a greater force to change or deform an object. We use the term stiff or stiffer. So A is stiffer than B. Is it clear? This example. Now some questions related to this topic. Okay, start with question 2 because question 1 was theoretical. So start with question 2. An experiment is carried out to measure the extension of a rubber band of different loads for different loads. The results are shown. So these results are shown. When there is no load, the original length was 15. Extension means the change in length. When we add a load of 1 Newton, the length is 16.2. What is extension? Extension means increase in length. If originally it was 15.2 and now it is 16.2, so how to find extension? 16.2 minus 15.2, so we'll get the extension. Then if we attach a load of 2 Newton, extension or increase in length is 2.1. So what is the original, what is the length now? So this is an increase in length. Original length was 15.2. So if originally it was 15.2 and it is extended by 2.1, so how much is the total length? The total length is 15.2 plus 2.1, which is equals to 17.3. Is it clear? Because we need a length. So length of a spring is original length plus extension. Original length was 15.2 and extension is 2.1. So we just add them to get the total length. Any doubt in this? Look, in this question, we have to complete the missing value. This is a missing value. We need a length. So length of the spring or total length of a spring is equals to original length plus extension. So original length means length without a load. So originally it was 15.2. And the increase in length, the extension is 2.1. So what is the total length? The length is 15.2 plus 2.1, which is equals to 17.3. A student add a load to an elastic cord. He measured the length of a cord for each weight. He then plot a graph for the results as shown. What has plotted on the vertical axis? What we should plot on vertical axis here? What we should plot on vertical axis?
Extension.
Extension. So which one will, options are A, B, C, and D. Which one is extension?
D.
D is the right answer, because how to get extension? You have the original length. Original length means length of a spring. Length of a spring without any load, that's called original length. And length of the spring with a load is called a measured length. So how I'll get the extension, because we plot a graph between force and extension. So weight is on I, x-axis, extension should be on y-axis. So how we'll get the extension? How we'll get the increase in length? The measured length minus the original length. Original length means length of a spring without any load. So measured length minus original length, what we will get? We will get the extension. And we plot a graph between force and extension, or weight and extension, or load and extension. The spring is suspended from a stand, the loads are added, and the extensions are measured. Which graph show a result of plotted extension against load? What's the answer? A, B, C, or D?
C.
Yeah, D is the right answer because it's starting, the extension is on y-axis and load is on x-axis, so it starts from origin. That's why D is the right answer. The spring is stretched by hanging a piece of metal from it. What is the name given to a force that stretches the spring? Which force is stretching this spring?
D.
The
Wait.
weight is actually stretching this. A student carry out an experiment to plot extension and load graph for a spring. The diagram shows apparatus at the start of experiment and with a load added. What is the extension caused by the load? How to calculate extension? What's the correct answer for this?
D.
Yeah, D is the right answer because it's the measured length minus original length. In this question, the object with different masses are hung on a 10 centimeter spring. So we hang an object from 10 centimeter spring. The diagram shows how much the spring stretches. The extension of a spring is directly proportional to the masses hung. What is the mass m of an object? So how we can identify?
C.
Yes, C is the right answer. That's correct. But how we can identify? Because the ratio should be constant. Like force divided by extension should be constant for n. If identical spring is there, F, so I can say first force divided by extension is equals to second force divided by its extension. Or I can say F1 divided by E1 equal F2 divided by E2. Whenever the spring is obeying a Hooke's law, the ratio should be constant. So F1 divided by E1 equal F2 divided by E2. So what is force 1? I don't have to convert into Newton because when we are taking a ratios, the unit conversion is not important. When you are taking a ratio of the quantity. When you are using a specific formula, then substitute in the formula with the correct unit is important. But when we take a ratio, we don't have to convert them into units, specific unit. So first what I can do, there are different ways to solve this question. First, I can find the value of the K. How to find the value of the K? Force divided by extension. Example, force is, the first example, the force is 100. And what is the extension? Originally it is 10 centimeter and then it is 20 centimeters. So how much is the extension or change in the length? So it's 20 minus 10, which is equals to 10. So K is equals to 10. Now, if I use the third equation, third formula, means the third spring. So for third spring, also K is equals to F divided by E. So K is equals to 10. F is the force which we are finding. And what is the extension? Its length is 30 centimeter. Originally, it was 10 centimeter. So extension is how much? Extension is 20. This 20 is divided. Other side, it will be multiplied. So C is the right answer. Is it clear? First, we got the value of K and we use the same value of a K and find the value of F. So you have to, or you can simply use a ratio. When two springs, identical springs are there, you add different loads. So F1 divided by E1 equal F2 divided by E2. So force 100, extension, because originally 10 become 20. So how much is extension? It's 10. Extension is always calculated from original value.
Ten.
Yes, you have a question?
No, I just said 10.
Okay, okay. So 100 divided by 10, and then force, we don't know, it's M, divided by extension. When you calculate an extension, it's always from the original value. So if its total length is 30, so extension for this example is 20. So this is 20. When you solve this, again you will get 200. Is it clear? Okay, in this example, so you have to use a graph. An object of unknown weight is hung. The length of a spring is 16.4 and original length was 15 centimeters. So what is it? And this graph is for force and extension, or force and load. So if originally it was 15 and now it is 16.4, original length of a spring was 15 and the new length of a spring is 16.4. How much is the extension? What is the extension of the spring?
1.4 centimeters.
1.4 centimeter. So if it's 1.4 centimeter, what you will do, you will draw a line from 1.4. This is 1.1, 2, 3, and 4. This is 1.4. Why? Because graph is given. So using a graph, we are finding a load. So from 1.4, you will draw a line on your graph and identify the load, which is equals to 3.5. Is it clear? So originally it was 15 centimeter. When you add a load, it becomes 16.4. The graph is between extension and load. It's not between length and load. So how to find extension? Extension is the final length minus the original length. So 16.4 minus 15, which is equals to 1.4. So we draw a line from 1.4 and identify what is a load. Is it clear? Any doubt in this part? So state Hooke's law, you will mention force and extension are directly proportional. That's Hooke's law. In the next question, for a force up to 120 Newton, the spring obey the Hooke's law. So till 120 it obey the Hooke's law. 120 Newton cause a 64 millimeter extension. On the figure, draw a force extension graph for a load up to 120. So when load is 120, this is 110, this is 120, and till 64. So 60, each box is representing 2. So 64 will be here. So the point where the two lines will intersect, so this is the point where the two point means when a force is one at this point, the force is 120 and extension is 64. And if it's obeying a Hooke's law, then it should be a straight line, which is starting from origin. Is it clear? Because it is obeying a Hooke's law, when a spring obey the Hooke's law, it should be a straight line which passes through the origin, and the last point where it obeys or continue to obey Hooke's law, we call that as limit of proportionality or proportionality limit. Then for next part, they ask, calculate the spring constant. How I can calculate the spring constant? I can take any point, because what is the formula for spring constant? Spring constant, or K, is equals to F divided by E. Force divided by extension. So what is the force? The force is 120. And what is the extension? Extension is given 64. So 120 divided by 64. What's the answer for 120 by 64? So
1.8.
1.8
875.
875. So 1.87, I took 3 significant figure. And then the unit of force is Newton, and unit of extension in this example is millimeter. So I will write Newton per millimeter. Why? Because here the length is given in millimeter, so it should be in millimeter as well. If it is in centimeter, then you will write Newton per centimeter. If it's in meter, then you will write Newton per meter. But most of the questions, the change in length is very small, so it's in millimeter or centimeter. In graph, if there is a weight, there should be extension. Yes, it is load and extension, weight or extension, or load and change in length. For Hooke's law, we sketch a graph for load and extensions. The third, student make a spring balance using a spring and maximum reading a student make a spring balance using a spring in B. The maximum reading on the balance is 150. The student tests his balance with a known weight of 140. He observed that the reading of a balance is not 140. What is the reason for that? Like, student make a spring balance